graphics cards can be loud. So when I built my current gaming PC many years ago, I specifically tried to buy a card that was as quiet as possible. And based on reviews, ended up with this ASUS ROG Strix RTX 2080. Unfortunately, it turned out that it wasn't actually very quiet. So one of the upgrades that I've made to my PC over the years are new Noctua fans for the graphics card. In this video, I'm going to show you how I replace the fans, and I'm also going to test them to see what kind of impact they have on thermals, performance, and of course, noise. The stock fans on this card aren't actually terrible, but they have a few problems. First of all, they are loud when starting from a standstill. You might think that this isn't really that big of a deal. I mean, you can just turn off the semi-passive mode and run the fans at a low speed all of the time. But the low speed where they work is around 30%, which on these fans corresponds to around 1000 RPM. And at those speeds, any fan would be audible. The last problem with these fans is that they will always go to 100% if the GPU temperature is too high. What exactly is too high? Well, I don't know because I didn't encounter it in my testing for this video, but it is definitely an issue. And as far as I know, this seems like a firmware thing which cannot be overridden by a custom fan curve in software. This annoyed me for a while, but then I came across a post on Reddit where someone had replaced the fans on the Founders Edition 2080 Ti with Noctua fans. And I wondered whether they would also fit my card. And it turns out that they did. Enter the Noctua NF-A9x14 hs-pwm chromax.black.swap. A bit of a mouthful, but an excellent fan. In case you didn't already know, Noctua are very well regarded in the PC building community as the makers of basically the best fans and coolers. They are very high quality, last a long time, and most importantly, are very quiet. Fortunately for me, they also make fans in a wide variety of sizes. As the name implies, this one is a 92mm fan, and it is low profile. That means it's only 14mm thick instead of a standard 25. It's also the high speed variant, 2500 RPM instead of 2200, and it has PWM control, and of course, it's black instead of Noctua's signature brown and tan, which doesn't really fit the aesthetics of my build. Now, an important detail about the fans is that they aren't actually 92mm wide. The frame is 92mm, so the actual spinning part is smaller. It's actually only 88mm, which turns out to be perfect, since the stock fans also have a diameter of 88mm. This means that I didn't have to get rid of the shroud on my GPU, as is sometimes done in, for example, small form factor builds, but I can instead keep the aesthetics and only replace the actual fans. This of course leads to the most painful part of this project, which was cutting out the fans from the frames with these. These aren't really cheap fans, so it wasn't exactly a pleasant experience, but it was necessary if I wanted to keep the shroud. Now, to remove the fans from this particular card, you first have to remove the shroud, for which there are 6 screws. 3 of them are on the top just behind the fans, and the other 3 are on the side. After this, you can unscrew the fans themselves. There are 4 screws per fan, and 3 of them are directly below the fan, so you have to screw between the blades. The fans are connected to the card with this white connector, so you also have to disconnect this. Now there's the case of how to attach the new fans to the card. I ended up 3D printing brackets that fit the original screw holes, and then attaching the fans to the brackets with double-sided tape. Unfortunately, because of how the fans are designed, I was only able to put in 2 of the 3 screws, and combined with the relatively low melting point of PLA plastic, it has resulted in the fans becoming a bit screwed over time. They are sagging a bit, as you can see, but after almost 3 years of this, they were still hanging on. Even so, I would probably recommend printing in PETG if you want to try this yourself, since it can withstand slightly higher temperatures than PLA. Now, I know that I can get away with PLA since I've been running for years, as I've said, and on a lower powered card it's probably also fine, but I wouldn't use PLA on something like a 5090. Now there's the case of controlling the fans. I don't know if it's possible to have the card itself control them, and honestly I don't care because of the automatic 100% fan speed thing. So I just got 2 PWM splitters and ran all 3 fans of a motherboard fan header. This gives me full control. I then use a piece of software simply called fan control, where I have made a fan curve based on the GPU temperature, which isn't possible in the BIOS or on the official motherboard software as far as I know. And that's it. Now they just work as they did in the first place, just much quieter. But what about performance? Is it better because they are Noctuas, or is it worse since they aren't necessarily optimized for this specific scenario, unlike the stock fans presumably are? I decided to run a few quick tests to find out. Let's start with the noise. I ran the fans at 3 speed levels. Full speed, 30%, which is the lowest possible for stock fans, and then something in the middle where I tried to match the noise levels. I settled for 50% for the stock fans and 60% for the Noctuas. This also resulted in a similar RPM. Take a listen. As you can probably hear, at full speed the stock fans are way louder, but that's to be expected since they are also way faster. The story becomes slightly more interesting at lower speeds. At 30% the fans are running at the same speed, but the Noctuas are quieter, to the point where the coil whine of the GPU is almost more audible than the fans themselves. At 50% and 60% respectively, they are also running at the same RPM, but the Noctuas aren't quieter anymore. At least on paper, according to my admittedly not very scientific decibel meter app on my phone. In practice, I think that the noise profile of the Noctuas is much more pleasant, since they don't have the same humming noise as the ASUS fans have. So overall, this is still a win for the Noctuas. Now let's take a look at temperatures. In Thermark, it's almost a clean sweep for the stock fans, as they win both at full speed, which was to be expected, and also at low speed. However, Noctua just manages to squeeze out a small win at medium speed, showing that at a similar noise level, they are actually competitive. If we move on to time spy, the story is similar for the temperatures, except that this time the stock fans win at all speeds all the time. Okay, so these Noctua fans aren't necessarily better at cooling the GPU, but am I leaving any performance on the table by using them? Well, if we look at the average clock speed in time spy, I wouldn't necessarily say so. The clock speeds are higher with the stock fans, but not dramatically. Logically, this should translate into slightly lower performance with the Noctua fans, but for some reason it doesn't. However, I must admit that I don't really know what's going on here. I don't think I've ever seen such a high graphics score on this GPU, even when using the same Noctua fans before. But I don't want to retest everything with the stock fans again, since this was just meant to be a quick video. So instead I would just take these results with a grain of salt. What I think we can conclude from this is that the stock fans are better at cooling the GPU. This makes sense, they are faster and probably more optimized for this. However, the Noctuas can still be competitive. And I don't think that you should be afraid of losing any performance at the very least. And of course they are also quieter and can also be run at much lower speeds, where they are practically inaudible. In the end, I think that it was worth it for me to switch to these Noctua fans. Whether it makes sense for you to do so probably depends on how loud your graphics card is and how annoyed you are by it. If you want to see a cheaper way of potentially improving the thermals and performance of your GPU, you can watch my video on phase change thermal pads right here. I'm planning to do a follow-up video on this, where I test how well it holds up after a year, so you can subscribe if you don't want to miss that. But that was it for this video. Thanks for watching, and I'll see you in the next one.